Okay, Advanced Algebra 2, 4th and 5th hour. This should be, what is today, the 14th, I believe. If I got that right, let me double check. Yes, this should be for the 14th. This is our last day of instruction. The due dates for these, again, are Saturday, so you get them done. I got to have grades in next week. I will explain in the post. I think I explained in the post that you can go back and make things up if you feel like you need to get that extra bump onto your grade. It'll show up for me that you've done it, so you can do that if you'd like. Okay. Today, chapter 11 was our right triangle trigonometry, so we're going to go through some examples here of SOHCAHTOA. So make sure you have a calculator handy, because we're going to look at two different types of problems here. So if we look at these two problems, on the first one we know what our angle is, it's 32. On the second one we do not know our angle. We got to find the angle, okay? So that's a little different. There's some different steps when you have to find an angle. But remember, in a right triangle, let me get that off there. Remember, in a right triangle, we can always label the side opposite of the 90 as our hypotenuse, okay? Wherever our angle is, here it's in the upper right, wherever our angle is, way across the triangle on the other side, that's called the opposite side. Right next door to it is called the adjacent. Opposite the 90 always has to be the hypotenuse. So then you look at this and say, okay, what do I have? Well, I've got an X on the hypotenuse and I've got a 15 on the adjacent. So I'm using adjacent and hypotenuse. That's cosine. Ka. So what's that tell us we set up? We set up cosine of our angle, which was 32 degrees, equals the adjacent side 15 over the hypotenuse x. And then the way we solved these was we could always slap that left-hand side over top of 1 and cross multiply. We would get x times the cosine of 32 degrees equals 15. And then since we're timesing by the cosine of 32 degrees, we would need to divide by the cosine of 32 degrees on both sides. And then we can just punch that in our calculator. Let me do that. Let's see what we get. Should be 17.7. Okay. So that's when you know an angle and you set it up and you just do a little cross multiplying there. Now when we don't know the angle, we still look to set it up the same way. We would say, hey, the 20 is our hypotenuse, it's opposite the 90. Way across from the x is our opposite, right next door to it is our adjacent. So this is another cosine. It's got the adjacent and the hypotenuse. It's another cosine. So we would say the cosine of x equals the adjacent side 9 over the hypotenuse 20. So now we want to find that x, or that angle. Now remember, to do that, then we're going to need to get rid of this cosine so that this x just falls down by itself. How do we get rid of a cosine or a sine or a tangent? We do the inverse. So we'll do the inverse cosine on each side of this. On the left-hand side, they would just cancel. It's like doing plus 5 and minus 5. They just cancel. On the right-hand side, it tells us, what it actually does is just simply tells us what to put in our calculator. And remember, to get the second, or to get the inverse, you need to hit the second button. So on my calculator, I'm going to type in, if you have a calculator like mine, second cosine of 9/20, and it tells me my angle is 63 degrees. Okay, 63 degrees. All right, so there's an example you can use, one where you have to find a side, one where you have to find an angle. Now in this chapter we also talked about our special right triangles, our 30, 60, 90s, and our 45, 45, 90s. This is something that'll come back to you again next year in your next year's math class. Do a lot of work with this when you get to that trigonometry stuff. Okay. There's the layouts, so hopefully you remember those. If not, you may want to write these down or come back to them whenever you get to your homework. But every single 30, 60, 90 triangle has that layout. So we can use those sides. So like if we were doing, let's say, we were going to do what can we do? Let's do the cosine of 60 degrees. So if we were doing the cosine of 60 degrees, we would just say, well, it's cosine, so I know that's adjacent over hypotenuse. Well, here's my 60. What's adjacent to it? A 1. What's the hypotenuse? A 2. So that means the cosine of 60 is equal to 1/2. Now what's interesting about that is it doesn't matter how big this triangle is. It could be a little bitty triangle like that. Or it could be a great big triangle with a 60-degree down there. All of them, the cosine of 60 would be equal to 1/2. And then here's the layout for your 45, 45, 90, 1 square root of 2. So let's say we were doing the tangent of 45. We would just simply say the tangent is opposite over adjacent. We've got our sides labeled, so what's opposite of my 45? Wait a second, I got two 45s. Well, the opposite on both of them is a 1. And the adjacent to both of them is a 1. So it won't matter which one you look at, you would get 1 over 1. You would say the tangent of 45 is equal to 1. If we did, let's do one more here. Let's say we were doing the sine of 45. We would say that's opposite over hypotenuse. Well, we go up to our 45, either one of them. Opposite of either one of them is a 1. Hypotenuse is the square root of 2. Okay. Now the only problem with this is we can't leave that square root in the denominator, so we would have to rationalize. Multiply by square root of 2 over square root of 2, and you would get square root of 2 over 4 over square root of 4, which is a 2, so we get a final answer square root of 2 over 2. So there's a problem on your short homework today. Over 30, 60, 90, or 45, 45, 90, so refer back to these layouts and the examples I just did. Okay, we'll see you.